Alright, part 2, number 2. If Mr. Harvey's car can accelerate at 5 meters per second squared, how long does it take him to get from 0 to 100 meters per second? Okay, so Mr. Harvey's car is going to go from 0 to 100 meters per second, and it's going to accelerate at a rate of 5 meters per second squared. So what do I know? Well, since my units right here say meters per second squared, I know this 5 number is going to be my acceleration. So I'm going to write that down. A equals 5 meters per second squared. Alright. Over here, I have that he's going from 0 to 100 meters per second. So since my units are meters per second, I know that these numbers are going to be velocities. So one of them is going to be my initial velocity, and one of them is going to be my final velocity. Well, he started out going 0, so that's going to be my initial. So I write that down. And then he went up to 100. That's going to be my final, so I write that down. And then the question is, how long does it take him to do it? So I'm going to be solving for t. So I'm going to go to my formula sheet now that I've written everything down and see which formula can help me here. That's going to be the formula we just used. This one has all the parts we need. It has an acceleration, final and initial velocity, and a time component. So let's see. I'm going to plug in all my numbers where they go. So we said A is equal to VF minus VI divided by T. So in this A spot, I'm going to plug in my 5 meters per second squared. Is equal to my final velocity, 100 meters per second, minus my initial velocity, 0 meters per second, divided by time. Okay. So we want to get this t, so the rest of everything else says t equals some number. So how can we get this t by itself? Well, if you guys remember, we talked about in class how to move this t if it's on the bottom and there's some other number here. So if you're trying to solve for something that's down here on the bottom and there's another number on the other side of an equal sign, you can erase the equal sign and instead draw a staircase. The one downstairs goes upstairs, and the one upstairs comes downstairs. So my 5 meters per second is going to come down here, and then my t is going to come all the way around and be up here instead. So I can rewrite that as t is equal to 100 meters per second minus 0 meters per second divided by 5 meters per second squared. And so when I solve that, the number that I get is going to be equal to 20. And my units, well, since I'm looking for time, and these are in seconds. Excuse me. I'm going to put seconds right here, because seconds are my normal unit for time.